Okay, in section 6.4, we discuss volumes of box, and I have drawn a rectangular box down here, and what we have is we have a box of some particular length, which means this side and this side and this side, the orange sides are all the same length. A certain height, h. The red here, this is the same height, same height, same height here. There'd also be a height in the back here, which you can't see, it's in the back. There'd be a length back here, which you can't see. And finally, we have the width. So the width here is the same as the width up here. And it would be the same as the width of this dotted line that I'm drawing there in the back, which you can't see. Well, altogether, if we want to figure out the volume, the total volume of this box, we take the length times the width. So that gives you the area of a square times the height. All right. So let's look at an example of that. Suppose, okay, I've copied a box down here for my example. I'm going to put some numbers in. Suppose my height was equal to 2. My length is equal to 4. And my width is equal to 3. Then for this box, the volume is going to equal 4 times 3 times 2 equals 24. 24 is the volume, 24 units is the volume of this box. Okay, so let's look at our box again. And let's say that we imagine that all these sides have an equal length, and they equal this length here equals 1 yard. The height also equals 1 yard, and this width equals 1 yard. So then our volume equals 1 yard times 1 yard. That's length times width times height. 1 yard equals 1 yard cubed, or 1 cubic yard. Okay, now we know that 1 yard equals 3 feet. So there's 3 foot in a yard. That's the length of a yardstick. So I could come and I could, let's do this with thin lines here. I could divide this up. Let's use a so I could divide this width here up into 3 sections, each of which is 1 foot long. So I could do the same with the top up here. And let's connect these with a straight line. So I broke this up into columns that are 1 foot wide. So this is 1 foot. This is 1 foot. This is 1 foot. Well, I could do the same thing in this direction with the height. I could break the 1 yard height up into 3 segments, each of which are a foot. So then I can stitch in these lines. See if I can get this to work out here. Here's another. So now I've broken this up. And I'm going to do the same with this whole cube. I'll go ahead and pause and do that. So I've gone and redrawn this. And again, this is 1 yard. This is 1 yard. And this distance here is 1 yard. So each of these individual boxes is 1 foot. So suppose I want to take this block out here, so I'm going to go ahead and delete this. So now there's a hole here with a block missing. Then if I pull that block and I send it off to the side, pause and do that. So I've gone ahead and I pulled this block out. All my thicknesses have changed. Pulled this block out from this portion down to here. We see that this is 1 foot by 1 foot by 1 foot. So this, the volume of this equals 1 foot cubed, or 1 cubic foot. 1 foot by 1 foot by 1 foot, 1 foot cubed. And we can see that really a cubic yard is made up of, if we count all these, there's 9 here, then the next column there's 9 more, and then 9 more behind. So 1 yard cubed, 1 cubic yard, equals 27 cubic feet. So how do we look at that mathematically? The volume equals, well, if this is a yard, we know that a yard is 3 feet. And if this is a yard, we know that a yard is 3 feet here, and the height is a yard, 3 foot here. So you can see that length times width times height equals, this is the same thing as 3 cubed times the foot cubed, because the feet also have to be cubed, equals 9 times 3 is 27 cubic feet. Well, we could follow the same idea with a cubic meter. And here, I've copied and pasted an image from the internet. So we have a cube here now, and this represents a cubic meter, where this side has length of 1 meter. This side has length of 1 meter. And of course the height is 1 meter. So this whole thing is 1 cubic meter is the volume. But notice if I take this yellow cube out, if I break this up into 10 segments here, 10 by 10, and then break this line up into 10 by 10, we'll see that that is a decimeter. So this tiny length right here is a decimeter, or 1/10 of a meter. So I pull that out, then you see this orange square here is a cubic decimeter. And then 1/10 of that, it's really little green dot here, 1/10 of that here is a centimeter, 1 cubic centimeter. That's 1 centimeter by 1 centimeter by 1 centimeter. And this is 1 decimeter by 1 decimeter by 1 decimeter, 1 cubic decimeter. So, if our volume then is 1 meter times 1 meter times 1 meter equals 1 cubic meter, then we know that there are 10 decimeters in each of these meters. So 10 times 10 is 100, times 10 is 1,000. So we've got 1,000 cubic decimeters in a meter cubed. And there are, think of this, 10 by 10 centimeters. 1 second. Okay, so there are, in 1 decimeter, this yellowish orange block over here, there are 10 by 10 by 10 centimeters. Or in other words, in 10 decimeters, there are 10 times 10 centimeters. Lots going on outside. I keep having to pause. So 10 times, there are 10 centimeters in every decimeter. So if there's 10 decimeters, there's 10 times 10, which is 100 centimeters in 10 decimeters. So I'm just going to put this 100 centimeters here. 100 centimeters. So in 1 cubic meter, there are 1 million cubic centimeters. So that's where we're going to end here with this video. We'll pick it up in section 6.5.